Hello, welcome to the OVP webinar. Sorry for a small delay. We had some technical difficulties, but we are obviously fine right now. So let's start with our today's topic. And we are going to talk about container security. My guest here from SUSE is Jarek. Jarek, if you could share a bit information, a small bio, so some information about you.
Sure. Hi, my name is Jarosław Biniek. I'm a pre-sales engineer here at SUSE, and my focus is on open source technologies, obviously on promoting open source, and today it's going to be about security and container security in particular. So on to you, Marcin.
Yeah, my name is Marcin Kubacki. I'm Chief Software Architect. My background is mostly infrastructure, but also the software development. And let's jump to our main topic today. So we know that security can be painful, and a containerized world actually makes the security even worse, even more complex. So how do you imagine perfect security? How can we address this part actually?
Yeah, definitely. So it's a whole new world when it comes to Kubernetes, and the thing is, let me start with a bold statement here that nobody likes security. And I'm sorry to you all security guys. That's just how it is. It's like brushing your teeth. We have to do it, but only because bacteria exist. And so security is like the thing we all wish wasn't there, but we have to deal with it. We kind of have to appreciate it also. So while we realize that security is necessary and it has to be there, we can imagine like how it could be, how we could do our operations, how we could run our workloads if we didn't have to deal with the hassle. I mean, we can't really get rid of it. It's not possible. We know the world isn't perfect. It's not like there's a story I read once that apparently the native Indians in North America, when they were first contacted, it turns out they didn't have a concept of stealing, even like in the language. They didn't have a concept of stealing. Sadly, we are not such a civilization. We have some bad actors, let's call it that, and hence the need for security. So the next best thing is, we can try to think of a better security. So how do we imagine that security? How would we like it to be if it has to be? So my sort of suggestion here is a few ideas. I mean, feel free to pop into the chat your suggestions. Of course, your input is appreciated, and we will answer any questions you have. So I will sort of start it, but feel free to continue and to add on to my sort of suggestions here. So the way I imagine ideal container security is, first of all, it has to be automatic. Kubernetes is all about automation, right? It's about taking this next step, and instead of running these cumbersome virtual machines with huge overheads, we run just small containers which are agile, which you can create them quickly, and you can delete them quickly, and it's all very volatile. It's all a lot of moving parts. So it's one of the challenges about Kubernetes security. But it's a quickly moving environment, and hence it requires some degree of automation to keep up with Kubernetes. Second, cloud native. I think it's, I mean, it may be obvious, but I think if our applications are cloud native, then it follows that security should also be cloud native. So it should ideally be run as a Kubernetes application and so on. Of course, security has to be effective, otherwise why bother? So of course, effectiveness and easy to use. I mean, let's not underappreciate it. There have been many cases where a good security solution did exist, but it was hard to use, and that was the reason why people didn't use it, or just used it wrong, or in some limited way or fashion. So easy to use is actually important, because for example, passwords. The more complicated passwords, the more complicated you make the requirements, the more users don't want to use the passwords at all. They try to find ways around that. So keeping that in mind, easy to use, I think it's an important requirement here. Moving on, easy to replicate. So with containers, we know that one of the major reasons for using containers is the ease of moving your workloads quickly, of migrating them. So we need a way to migrate our security together with our workloads, with our applications. So that's why I think that's also a very important quality, if you will, of Kubernetes, ideal Kubernetes security. And finally, I think being able to manage security as code is also essential. Why is it essential? Because we manage everything else as code in Kubernetes. It's all described by YAML in one way or another. So even if we do our management using some kind of graphical user interface, underneath it's still code. So so security has to be the same in order to keep up. And so we want a way to replicate our security settings, to save them, to move them, to manage them as code, and to version it as code, to use the same approaches that we use for development.
Okay.
So that's my that's my thesis here. That's my hypothesis. That's my suggestion.
No, that sounds that you have to prove it to me. So now these ideas are perfect, but how do you imagine we could address them?
Yes, exactly. Well, it's one thing to dream big, of course, and it's another thing altogether to actually realize your dreams. And when it comes to security, realizing that dream comes in layers. Security is all about putting as many obstacles as you can between the attacker and your data, right? And container security is no different in that respect. And with that in mind, it also has to consist of as many layers as it reasonably can. And but before I go on to describe these particular layers, I would like to first highlight this important distinction, and it's between scanning for vulnerabilities in some fashion or another, and between doing real-time network traffic inspection. And it's an important distinction to make, because you can only scan for things that you already know, right? If you know there is a vulnerability, there is a CVE or something, then you can look for it, and then you can try to defend. But if you take this analogy and compare it to driving a car, that would be like driving your car, but only looking in your rear view mirror. So you only see what's already happened, and you have no way of looking ahead of you. And the only way to defend yourself against unknown threats, against future threats, is via traffic inspection, is to look at the data as it is being processed, and to look at the packets as they travel, and to look for irregularities there. So it's a very important distinction. Now, of course, that's not to say scanning is not important. Absolutely, it is. It's just it's not enough. Just forget about patching being your security strategy. Patching is no strategy at all. Patching is absolutely necessary, but is not enough. That's my main point here. So with that, let's move on to describing the actual layers, the actual obstacles that we can put in the way of an attack. So I made this distinction, sort of made this division here into supply chain security and runtime security. So one is the rear view mirror, and the other is looking at what's ahead of you. So we need both, and we need to do them as well as possible. So supply chain security means scanning for CVEs, of course, scanning for your compliance if you need to be compliant with some security guidance, and it's also including admission control tools. So choosing which thing to allow to be run in a way. So admission control is kind of almost runtime security, but it's kind of in between a little. But I call it arbitrarily admission control. So I call it supply chain security. Anyway, with runtime security, we can do runtime scanning, which is scanning of the actual workloads, the actual commands being run, and actual things being executed in real time. It also it can include some thread-based controls, so it can include some looking for some patterns that we expect maybe may emerge if we are under attack. And finally, zero trust controls.
Okay, so if I understood correctly, this runtime security kind of corresponds to looking ahead of us, and the supply chain security is looking backwards, like in the rear mirror, right?
Exactly, yeah.
So, okay, so let's see how we can then look forward, look ahead of us with runtime security.
Sure. Let's break it down a little. We have the thread-based controls. So with some kind of idea that we have about the possible threat, And then we have zero trust controls. Zero trust is a big topic in and of itself, but I'll get back to it in a minute. Let's talk about the thread-based controls first. So here we have CVEs, but CVEs in terms of vulnerabilities of containers being run at the minute. We can also look for some particular data in our network traffic. For example, credit card numbers or some other social security numbers and other personal data. So we can look for these patterns and try to catch them as they happen. There's a whole group of network attacks that can happen also in this sort of runtime layer, so in this application layer. And I'm talking about attacks that will not be visible to a ordinary firewall or to these classic data center security tools. So, for example, a DNS tunneling will not be prevented by a classic firewall because it's a DNS query, right? And the same with SQL injection attacks and this sort of thing. It happens at application layer, and that's the layer that we need to defend if we want to be really secure. I mean, on top of all the classic firewall tools. I talked about admission control. I mean, in the context of Kubernetes, it just means usually some kind of selection, some kind of criteria for which images are allowed to be run in our cluster. So with that out of the way, let's talk about zero trust, because that's it's a bit of a buzzword in the security world, and it's widely overused, is widely misused. And what does it mean, and how can we achieve it? First of all, zero trust is an approach, a philosophy that assumes that everything not explicitly trusted is untrusted. So basically, the default for everything is untrusted, is blocked, and we only allow things that we explicitly mark as trusted, as whitelisted. So that's in contrast to the sort of traditional security where you in contrast, maybe it's a big word, but it's a new way of looking at things. And zero trust can include network connections. So we can mark certain connections as allowed, and all other connections will be implicitly disallowed. And the same with processes and files accessed, and all of that would be quite complicated to capture manually. So we designed a tool that does it for you, and it's. I think it's probably time to introduce the name of our security solution that I'll be presenting today and demoing today. It's called New Vector, and it's unique in that that it can automate this learning process. So what it does is it looks at the traffic as it's happening in your cluster, and it learns all the patterns. You can modify it, of course, but it will do most of the legwork for you. And,
so if I understood correctly, it may also learn the bad connections during the learning process, right? So something that,
Absolutely, yes, absolutely, that's correct. That's why it's well, you as an administrator, as a security person in your data center, you are still necessary. It won't replace you because you know what traffic is valid and what traffic is suspicious. So at the end of the day, it's up to you to look at what NewVector has learned, has recognized, and decide if it's okay, or maybe if it's something fishy and should probably be deleted. I mean, a rule that should be deleted. Yeah, and once you have all of that, all of the rules, whether automatically learned or whether you designed them manually, all of that can be saved as code and can be reused, can be managed as code, can be migrated to another cluster, and a bunch of other things that we'll talk about in a second. So what all of this does, all of this zero trust thing, it creates a sort of virtual patching, which means you can defend yourself successfully against zero-day attacks, against unknown attacks. Because if you were very careful in your policies, or if you just let it learn if you let the NewVector learn it correctly, then you have all your proper network traffic marked explicitly, and any kind of attack will inevitably have to create some other network connection, some connection that is not explicitly allowed, right? So, and this is where we will catch it. And if not, then there has to be another process that needs to run. We will catch it. If there's a file that's accessed, we will catch it. So there's a number of obstacles that we put in the way of an attacker, even if it's an unknown attack, even if it's some kind of exploit that we didn't even know existed, right? So that's the power of NewVector here, and I think it's probably worthwhile to mention also the fact, because I don't think I mentioned it, but NewVector also gives you full visibility of your network traffic, right? Because you can. I mean, you can use your firewall, your level 3, level 4 firewall, but it will be kind of blind to what's happening inside of the Kubernetes cluster. Kubernetes uses its own overlay network, and that's kind of a black box to traditional security tools, right? So in order to uncover this black box, you need to have proper observability into the network traffic inside Kubernetes. And that's what NewVector does, and it does in a very clever way, I think, because it does it by well, actually, let me skip a few things here and move on to this component here called Enforcer. This is a component that runs as a daemon set, so it runs on every Kubernetes node, and it's run right next to a virtual switch, and it's a position where it can easily inspect all of the traffic before it even really goes anywhere. So as it is being rooted, it can be intercepted by the enforcer component.
So this is a kind of the operator that you provide, right? So it installs enforcer, scanner, web UI, and so on, right?
Yes, because well, actually, but thank you for asking. Yeah, because NewVector is a cloud-native application, and it is deployed as containers in a Kubernetes cluster, and so each of these components here is basically a container, and yes, and Enforcer is actually being run as, like I said, as the daemon said, in this perfect spot for intercepting any traffic. And it's our own technology. Actually, it's not based on eBPF. eBPF is, I mean, we do use some elements to make it more efficient, but we don't have to. It's kind of optional. We can kind of bypass eBPF altogether. So we are not interrupting the kernel in any way. And also going back, the scanner components, they allow they allow us to utilize the Kubernetes power of easy paralleling. So we can just replicate scanners, and if we have a big repository to scan, we can just easily make many copies of scanners and just blast through all that scanning. Yeah, and going back again, the architecture is kind of similar to Kubernetes itself. We have a control plane which provides API and is kind of a central brain of it all. And then we have, of course, a component that has a graphical user interface and provides CLI as well, and then enforces, as I already described. So with that kind of out of the way and described fully, I would like to go back to
pipeline, so we can integrate that.
Yeah, yes, because one of my initial these ideal characteristics, right, of a security solution was to be automatic, to be agile, and to be deployable as code, etc. So that's what we did essentially, and we can include not just the Kubernetes cluster itself in our security environment, but we can shift left our security all the way back to the point where we are building the container images. So we, of course, we do the registry scanning, we do the admission control, layer 7 firewall, etc. So we do all that, but we can go even further back, and we can now implement the security as code and add it to build it into the container image, essentially.
So if I understood correctly, on the previous slide in the architecture, at least it gave me an impression that it is mostly about the runtime part. But now if I see the pipeline, if I run a pipeline in the Kubernetes, I guess it's a Tecton based, maybe? It's a part of a Tecton pipeline, or it integrates only with the specific vendors of the pipelines?
Yeah, it's actually vendor independent. We can work with many different CI/CD pipelines. So it's actually.
So we just need to invoke a component of the.
Exactly. Yeah. Just
it just scans. Okay. So I see security policy as code. So okay, and now I see that I'm scanning registry. So for all of the images. And during the build, will I have some output, some kind of information that I'm building right now the wrong image? It has some vulnerability.
Well, it's even better than that, I would argue, because the idea is that your workload, as it's running in Kubernetes, it has some security settings, right? It has some policies attached to it, and now we want these policies to be attached to it as soon as it is being built. So when it is being built, it has the security settings built into it, and when it reaches the runtime stage, when it is being actually run in Kubernetes, it brings its own security with it. So you can essentially work with the security as code, all the way back at the image building stage.
Okay.
So what this does is it avoids quite a few pitfalls potentially, because I mean, for one, your developers will be well aware of the security settings being baked into the image, right? So that's one thing. They will have the awareness. So it won't be like say security changed some policies and now the application is broken, right? It's going to be far more intelligent and automated.
Okay, but so you have mentioned that I write the policies and during the build it is able to evaluate. So I'm able to define the policy as a code, right? In this case.
Yes. And the code is actually similar to Kubernetes code, which is YAML, of course, and we can define what application behaviors are allowed, what it needs to run, essentially. So that's why it's why it's so great, because it's a clear sort of description of what it needs to run, and it's easy to talk now. Developers and security, they can easily tell what's going on, what do we need, or what is the current state, and it makes migration very easy because you have the same security settings in all your staging environments, not just in production. So that's one extra benefit, but it won't surprise you when it goes into production. Oh, now its security is different, and now it's broken. No, it has the same security settings because it's kind of baked into the image itself. And what it looks underneath, I mean, we can just quickly go through it and then break it down, what it contains. So first we have egress. So what kind of traffic is allowed going out, and then ingress, what incoming traffic we allow. What ports possibly we can limit port. We can list explicitly the files that are allowed to be accessed, and also the processes. So it's essentially a full description of what an application needs to run properly and to function while being secure. And finally, a policy mode monitor. Now, this I will explain it in the demo because I think it's going to make much more sense if we make it if we just show it on screen. So bear with me as I bring my Kubernetes cluster up, and This is Rancher interface. So for all of you who are familiar with Rancher, that's our Kubernetes management platform, which I highly recommend. And it offers an integration with NewVector, so you can have single sign-on with NewVector, but it's not required. NewVector works with any Kubernetes on the market, including OpenShift, Tanzu, and others. Let us look at some policies here. Let me find a container. For example, let's see. We have an example app here deployed. That's it's a kind of like a shopping, an internet shop essentially. And now what we have here is it says discover, policy mode discover, and it's a default mode that NewVector starts with. But we can switch modes between discover, monitor, and protect. Now, what are the differences here? Discover, as you may have guessed, is the mode where NewVector is learning about its environment. So it's listening, it's mapping out, it's writing down what's happening, coding it as policies. So it will discover, but this container here, for example, it made these connections here. It made connections to another container with these ports, and so it is allowed because by default we allow it. But we can use a different mode. We can use a mode that's called monitor. And what monitor does is we no longer learn anything. We decide, okay, that's it. That's our policy, and now we want to know anytime this policy is violated. So we put a freeze on our security settings, and now we want to be informed when any of that is violated.
Can I automatically later, or maybe not automatically, but manually add this rule later from some kind of list? So I see that the rule has been violated, and that's another connection to some extra system that I previously haven't had on my list. And I just want to say, okay, that is fine.
Yeah, exactly. We can go to security events where we will have all the information. Thank you. Great question, by the way. And from there we can review the rule, and NewVector will propose a rule for us. So for example, if we decide that oh no, it's been blocked, but it's actually okay, we need this to run, then we can just go and click deploy, and there you go. It will no longer be flagged as a violation, right?
Okay, and now if I have an existing rules and policies, actually, I can modify obviously and say no, this process is not okay.
Yeah, absolutely. Yeah, you can anytime you want to go, you can just go to any container, go to any process rule, and just delete it if you want. You can like for example, here we have only these basic rules, and oh, I know why I can't modify it, because it's been imported with custom resource definition, right? So it's actually
maybe those learned that you have a little bit higher.
Yeah, exactly. The ones that you have learned is you can actually edit and delete. So that's you have full control over that. But CRD is actually a rule that's been either imported, so we exported a rule from another cluster possibly and imported and applied it here, or it's a rule that's that the container image contains because it was baked into the container image, right? It's a custom resource definition that defines it.
And another question, because I'm curious, in the architecture that you have presented, I've understood how can you prevent network, let's say, the actions on the network layer, because you are in the middle, let's say. But
Yeah.
how do you prevent process from being started? Do you need some kind of sidecar pod that needs to be deployed along with all of these applications?
Actually, no. New Vector. New Vector can work alongside sidecars. They are okay. For example, if you say you use a service mesh, and it will typically involve sidecars. So that's absolutely okay. You can do that, but New Vector as such doesn't require that to work properly and to prevent processes from being run. Well, it just does it from Kubernetes layer.
So on the node level, you are able to detect namespaces and connect to each of the namespaces and fetch the processes from there.
Yes, actually, we can look at our environment on many layers. I mean, this is the rear view mirror, if you will. So we can look at vulnerabilities in the Kubernetes layer. So that's platforms. This one's fairly new, so it doesn't have any CVEs. Then we can look at nodes. So each node can have some vulnerabilities, and finally we can look at containers in particular. So each container we can also look at what the processes are running, and even a little stats of like CPU and memory and so on.
And this is reactive. I mean, whenever I execute any malicious code and it creates a new process, you will instantly be able to block it, or you are periodically scanning the host?
It's both, actually. We can because we are scanning for vulnerabilities in a reactive way, like you called it. So for example, these CVEs, and we are we give you all this information about any potential dangers, but also we can intercept any sort of process, which is what we do here in groups, where we can. Where was my? Yeah. Where we have the process profile rules or file access rules, so we can modify it all here. One other thing I think I haven't mentioned yet is or haven't shown is DLP sensors. For example, like I mentioned, for credit card detection and such similar things. So we can actively monitor our traffic for a particular set of data. So, for example, if we need to deal with credit card numbers, and it's a very sensitive data, then we will be able to detect this data even if we fail to notice somehow the attack that's happening, right? So we can still catch it just by realizing that, hey, this data is being transmitted where it's probably not supposed to. Right. So I think just one last look before we wrap is the dashboard, where we have this sort of overview of our security, and we can look at our security events, our which pods or nodes are the most insecure, and so on, and also layer 7 detected connections. So as you can see, we actually inspect traffic at layer 7, and it's very, very important for the layer 7 to be actively monitored, like I said earlier, because of these application level attacks that will evade level 3, 4 security tools. Right. I think that's
End of the demo.
yeah. I think we'll go back to the presentation, and let's just briefly recap what we've learned. The most important thing I want you to remember from this is that scanning, patching is not enough. It's important, but it's not enough. You have to look ahead. You have to inspect traffic in real time at layer 7, and ideally also look at processes and look at files, and to be able to create policies to actively block anything that's out of the ordinary, that is not explicitly allowed. Well, just one last slide from me with this sort of encouragement to if it got you interested, if you want to learn more about NewVector, about Kubernetes security, and please feel free to get in touch with me, with our SUSE office. And of course, to try NewVector, it's open source. It's available for free. Of course, you can also buy a support subscription from SUSE, but it's if you want to just test it, then feel free. It's there. Let me just quickly look at our. Do we have any questions so far?
Yeah, so actually we can jump into the Q&A session right now. Please write your questions in the questions tab or in the chat, so we will try to answer your questions.
Well, Kubernetes security is so complex that I refuse to believe that there's no questions. There have to be. So come on, be the first. Well, in the meantime, maybe I'll just quickly recap. Also, NewVector as a as a security tool. So it gives you this ability to scan your environment, scan your Kubernetes, scan your nodes, scan your image registries. I haven't actually shown.
Actually, that's actually a good thing you haven't mentioned that, because previously I thought that actually we are focused on the running environments, but you also mentioned that we are able to scan nodes, so physical Kubernetes part, right?
Yes.
So
yes, exactly.
does it cover also the operators, for instance? That's obviously a part of the container. It's containerized, so I guess it's supposed to, right? So if I have any vulnerabilities in the running operators on the Kubernetes.
Yes, I mean essentially it is a container, right? So we can scan it. Yeah. And Yeah, and the same thing with nodes. There's no real distinction between I don't know, between virtual nodes or cloud nodes or SUSE or Red Hat nodes or some other. It all is. I mean, a new vector can handle all of it. We at SUSE.
Okay. I guess we don't have any questions. So if anyone has any additional questions, you can also write to us. So Jarek, anything else you would like to add, or?
Well, I think that's it from me.
Okay, so thank you for watching our today's webinar. I really enjoyed it. This is kind of something new for the Kubernetes ecosystem, especially that security is becoming more and more important in today's world. And write to us any questions if you have, and stay tuned for our next OVP webinars.
Thank you. Goodbye.